Still can't hear me?
Yes, I can hear you, Miss.
Okay, right. So can we start the class now? I suppose all of you are here. Guys?
Yes.
Boleh, Miss.
Ya, boleh.
Yeah. Okay. All right. Assalamualaikum and a very good afternoon. My name is Ain Afina. You can call me Miss Ain. So I'm going to conduct this lab. As you guys know, there are 3 GAs. There are 3 of us. So we're going to do it by sharing the class, by rotation. But yeah, it's going to be okay, okay? So I suppose that Mr. Nuruzaman had already like tell you about all the lab reports in a very detailed manner before this. Am I right?
Yes, Miss.
Okay. So I will not go any further into the lab manual. We're gonna like start on this experiment right away. We're gonna focus on this experiment because I suppose you guys already know. I mean, is it handwritten? Is it by group? And it's the same with me. Okay. I'm going to type in my email address here. You guys need to submit your lab reports in the same manner to me. But I need to remind all of you, please send your lab reports to me by 22nd of June. Actually, yeah, Doctor asked us to send your lab reports 2 weeks, fortnightly, 2 weeks after your lab. Okay? Is it alright? Everybody?
Sure.
Okay? So I'm going to start. Alright, I'm going to start. First of all, let's us look at the lab manual first, briefly. Okay, can you guys see the lab manual?
Yes, we can see it.
Okay. Okay, so let's start. Okay, today is the AC Asynchronous Mission Laboratory. So there are the same like previous experiment. There are three sub experiment, okay, in this experiment. So first of all, this 2.1 no load test. So this experiment is performed on 3-phase squirrel cage motor, and the objective is to meant to compute the no load current and the no load power factor. So like basically we are going to comprehend and understand the working mechanism of asynchronous machine without any external factor. I mean, directly we're going to record the current and the voltage and so on. Okay, so let us look at the theoretical review. The power absorbed by an unloaded asynchronous motor is only caused by mechanical losses and Joule losses in the stator and rotor, and absorbs a low current and rotates close to synchronism speed. Okay, these are the formula, and these are the formulas that you guys need to calculate and write it in the lab report. Okay, and discuss it. And so these are the components involved: squirrel cage asynchronous motor, power supply, cables, 3-phase analyzer. Okay, I would like to ask you here, can any of you identify the difference between this circuit of asynchronous machine and the circuit of synchronous machine that you guys have learned previously? Can any of you like uh raise your hand or tell me the difference that you guys can identify from the circuit diagram? Is there any response? Okay. Okay. So okay, then I'm going to proceed. So basically, there are no generator involved. Okay. So we're gonna straight up uh, measure all the voltage and currents directly from the motor. So we are going to look at the connection later. Okay, so in this experiment, what we are going to do is we're going to supply the voltage. Okay, switch on the power supply and supply the voltage from the power from okay, we are going to supply the voltage to 222 volt and then vary the voltage. Okay, vary the voltage. I mean, we're going to adjust the voltage to 100 to 120% from 2 to 0 volt. So you guys have to calculate it. Okay, how much is 120 to 2 to 0 volt, and then 100% of 220 volt, 80% to 220 volt. Okay, gonna write it here, and then from there uh, you can identify and record the armature current, the power, wattmeter 1, wattmeter 2, wattmeter 3. Basically, what you guys do in physical lab is to record it. And for no load power factor, you guys need to calculate it, okay? And show it in the lab reports. You guys clear?
Yes, madam. So far.
Alright, okay. So if you guys need to ask anything, just directly ask, okay? So I'm going to proceed. Okay, plot the graph. Okay, I'm sure you guys already like kind of like have a basic idea what to do. Plot the graph, current power factor versus volt, and while doing the plotting, find the correlation. What happened to the power? What happened to the current if the volt is increased? You know, discuss that. It's that information that I want to see that you guys are going to discuss in your discussion in the lab manual. Okay. And then next, going to have a short circuit test. The objective is to compute the short circuit current and power factor. So these are the calculation that you guys need to do. The same thing. Okay, so basically what we are going to do here is to short the current by induce the rotor mechanical lock. So we're going to lock with a rock the asynchronous motor with the rotor. Okay, and we're going to find out what happens if we short the circuit. Okay, so for the previous experiment, what we did is we vary the voltage, but this time we are going to vary the armature current. Okay, by inducing the voltage, increasing the voltage, it's like at the power supply, you guys kind of like, what you actually do is increase the voltage at the power supply slowly, and at the same time, you guys are going to like detect the reading. at the analyzer. Okay, and there's a armature current reading there. Like increase the voltage until you get the armature current of 0.6 ampere. So you guys have to vary the current by uh, decreasing or increasing the voltage. So like increase or decrease the voltage until you guys have 100% of 0.6 ampere, which is 0.6 ampere, the armature current. So 80% of 0.6 ampere, like record the value here, okay, until 25%. And the same thing, you get a reading of armature voltage, wattmeter 1, wattmeter 2, wattmeter 3 at the analyzer. Okay, basically that's what we do in the physical lab. Alright? Boleh? Okay, and plot the graph. Okay, so experiment 2.3, determination of working characteristic. Okay, what you guys do is to load it with the brake dynamo. Okay, so by like connect the brake dynamo with the motor, and the brake dynamo will be connected to a rheostat, and at the rheostat we will vary the load, because this time it's going to we are going to introduce the external factor, which is load. Okay, we're going to vary the load through this rheostat from 6, 5, 4, 3, 2, 1. And here's the circuit. We're going to go through it later. Okay, so before we induce the load, we need to calibrate. Okay, calibrate the brake dynamo, which is actually we put like we're gonna like put in the 5 Newton of weight at 0.11 distance from the brake dynamo, and you get a torque reading of 0.55 Newton meter. So this is we're gonna calibrate it first. Okay, this is I'm explaining to you what actually happens in the physical lab. All right. And then for the worksheet, like, okay, we're gonna increase the voltage from power supply 4 to 220 volt, for power supply 1 to 380 volt. And what we gonna do is to vary the load, okay, at the rheostat, load 6, 5, 4, 3, 2, 1. So when we induce the load at 6 and record all the armature voltage, armature current, arm length, torque, and these are all data that we're going to get from the from the analyzer. All right. And speed, actually we need to use the speedometer, but you guys won't see it at the simulation. And for power input, power output efficiency, this is you guys have to calculate it, okay, with the calculation given. Write it, okay, plot the graph, discuss the graph, and discuss this asynchronous machine, okay. So from this, you guys kind of will have an idea the difference with asynchronous machine and the synchronous machine. So you guys understand?
Madam,
Yeah.
the graph should be the baseline fit, or we just have to draw all the points.
Can you repeat
The
your
graph
yeah?
the graph should
Mhm.
be the baseline fit, or we should just match all the points.
Um, Actually, I would prefer you guys like do it separately, but then you guys can do it separately, and then match all the point in one graph.
Okay, madam.
Okay, can you understand what I mean?
Yeah, I understand.
All right. Okay, thank you. So we're going to start. Can everybody? Get me? So because I'm going to start with our simulation right now. So, okay, as we are doing our simulation, please refer to your lab manual, okay? Okay, so asynchronous machine, to compute the no load current and no load power factor. Okay, identify the power supply. So you guys, hopefully you guys are already expert on it. So this is how the power supply. Okay, all of this. The whole thing is the power supply. Alright. And then three-phase analyzer is this. Okay. Basically, this is where you guys will get the reading. The volt reading, the ampere reading, it's all here. And squirrel cage asynchronous motor, of course, it's this one, right? Okay, so now we are going to connect the alternating current, first phase of three phase, from power supply to the three-phase analyzer, right? So just connect it from L3 to R, L2 to S, L3 to L1 to T. Okay. And then connect the input terminals of the emitter to the corresponding output terminal of the emitter. So basically at the analyzer, this is the input terminal, this is the output terminal. So just connect them. So yeah, what you guys doing physically, if in a physical lab, you guys gonna have a cable and connect them, right? Okay, next. Connect the input terminal of voltmeter to the corresponding output terminal of the voltmeter. So this time it's voltmeter. So connect it so you get the output. Okay. Boleh? Can everybody?
Boleh, madam.
And okay, thank you.
Boleh ada.
Alright. Okay. So after you connect it, so of course you're gonna like connect it to the asynchronous squirrel cage motor, right? So like you guys can click for hints what to do. So basically connect the L1 to IU, BL2 to BL to V1, BL3 to WI. Okay, next. After connect at the squirrel after connect from the power supply to the analyzer to the squirrel cage motor. So basically you guys have to neutralize it, alright? So neutralize the squirrel cage motor. Alright. So you guys will get the reading. Okay, these are the table that I already briefed you. And yeah, copy the reading, but don't just copy. Okay, comprehend the reading, do graph, discuss about it. Alright. Okay, so we're gonna go to the next short circuit test. To the next slide, short circuit test. So what we are going to do is to compute the short circuit test current and the power factor. So engage the rotor mechanical lock at the squirrel cage asynchronous motor. So this is the squirrel cage asynchronous motor, and there will be a lock. Okay, engage the rotor mechanical lock. So basically, by locking the cage is like it's a short circuit. Okay, it means that at the same you guys are doing a short circuit by locking it. Okay, so just very okay. Nanti say rotor is locked. Alright. I'm going to show you some photograph later so that you guys can have a better understanding about this, right? So next. Okay, so basically after we lock, so it is the same as we short the current, and these are the results. And discuss all the results. What happened after we short the current? Okay, what's the difference? And for the third experiment is the determination of working characteristic. Right? So what we are going to do here to determine the motor load characteristic using a brake dynamo, we're going to measure the torque and the mechanical power of the motor at various load conditions and to calculate the efficiency of the motor. Okay, you guys gonna understand better when we do simulation. Alright. So, okay, you guys have familiar with the power supply, the analyzer, the squirrel cage motor, asynchronous. Okay. So, where's the brake dynamo? Where's you guys think is it? So basically, what you guys can understand is, it said in the lab manual is to connect the brake dynamo to the squirrel cage. So this is the brake dynamo. Okay. Identify the brake dynamo rheostat. Okay, this is the rheostat that I tell you previously. This is where we're gonna vary the load. Right? Multimeter, of course. Okay. Now we need to engage the brake dynamo with the squirrel cage asynchronous motor. This is the brake dynamo. Drag it and engage it with the asynchronous motor. Okay. Next. Provide the direct current to the brake dynamometer. Okay. And if you guys can click for the hints if you guys need some hints. DC from section 4. Okay. So this is section 4. Positive terminal and connect it to B1. Alright. And negative terminal, connect it to B2. Okay. So after we connect it with the brake dynamo, of course we need to connect the circuit with the rheostat. So using the rheostat, provide the resistive load to the armature of the brake dynamo while measuring the excitation current using the multimeter. Okay. You guys can click for the hints. Okay. So what we the first thing we are going to do is to make the rheostat parallel. Is to parallel the rheostat. Okay. And then, alright. Connect and now to measure the excitation current, connect A1 to the amperage of terminal to the multimeter. A1 to the multimeter. So A1 to the amperage of multimeter. Alright. And then connect the common part of the multimeter. This is the common part of the multimeter to the lower terminal of R3. Okay. And finally, connect the upper terminal R1 to A2. R1 to A2. Okay, so you can see that we have a full circuit. Okay. Connect the load cell to the torque meter. This is the torque meter. Torque meter is where you get the reading of the torque. Okay. Connect to the load cell of the machine where we already connect it with the load. Right. So basically, what in the physical lab, what we are going to do is to, okay, you guys can see here, vary the load, okay, from 6. Okay, turn the connection to the 6 and get all the data from the analyzer and the multimeter. And then it goes to 4, it goes to 5, okay, and then 4. So basically, that is what we are doing. Okay, these are the results value. As I tell you, the speed actually we need to use a speedometer, so it's not there in the simulation. Okay. Record all this in your lab manual. In your lab reports. Discuss it and plot the graph. So yep, basically that is all for the experiment. So can you guys hear me?
Yes, madam, you can hear.
Okay, so yeah, basically that is all for the experiment. So is there anything that you guys need to ask? Am I going too fast?
Madam, actually, I have one question.
Yes.
Okay, for the lab report, we should write the theoretical review, and then, if I'm not mistaken, Mr. Zaman said we have to add in some more other informations. Am I right?
Yeah. Yes.
Okay, like where should we find the information? Because I've been searching a lot for the
Mm-hmm.
past lab report, but then memang tak dapat source dia information. And then example for this 2.1 no load test, nak add
Mm-hmm.
information related to no load test ke, related to asynchronous machine ke, it's like complicated. So madam can explain a bit more about that.
Okay, first, okay, try to find the information on synchronous mission first. Okay. Just brief information. Okay, you guys can find the information. I mean, mm, try to find a suitable source. Okay, rather than just Google it. Try to find the journal or whatever, or also from your notes. Just a brief information. As long as I know what you are doing, you can understand. Okay. For example, what I understand is that asynchronous machine is machine that the motor rotate speed less than synchronous speed. Okay. Even that one of 2 points of the information is valuable. After after you guys has discussed about the asynchronous machine, then you can tell one or two things of the no load test. So basically, no load test is the test that we directly measure the volt, the machine, the volt, the current without any external factor. So that means it's the working characteristic of the asynchronous machine. Without the load, how the machine works. So basically it's like that. Just try to find the information from the web, from the journals. Okay, I'm not asking too much, just enough that I know that you guys actually understand this, how this machine works. Is it okay? Am I answering your question?
I think it's okay, madam. Understood. Thank you.
Okay, so is there any more that you guys want to ask me? So is everybody okay? Okay, can you guys give me a response? 1 or 2% here.
Okay, Miss.
Okay, madam.
Okay. So if everything is okay, I'm going to end our lab. And yeah, I need to remind all of you again, please submit the lab report 2 weeks prior the lab. Okay, so that means from today is 22nd. Please submit the report. Okay, I will tell you my email. Okay, I will type in my email here. Okay. Please submit the lab report to me on 22nd. Please submit it on time. As we all know, we have like a lot of other lab reports to write. Okay. To mark. Sorry. Okay, I'm going to type it. Okay. So I already gave you my email. So if there's anything, you can contact me by email. Alright. So that's all from today. So I'm going to end the discussion. Thank you. Thanks you guys for your attention. All right.
Thank you, madam.
All right. Thank you.
You're welcome.